For homework of section 4.5, the linear differential equations, please do the numbers on page 420, problems 225, 31, 33, 41, and 49. And when you've finished, come back and I want to talk about it. Now that you're done with the homework, which there aren't very many problems, what, 5 problems? That's because differential equations, at least the first order linear differential equations, follow a set pack of rules. Okay, and we just follow the rules and the answer will come out. So there's no real reason to do a whole ton of these things once we get a hang of it. So the principle, the rules that we're supposed to follow is step 1, we write the equation into a form where it says y prime plus px y equal to qx. And rule 2nd, we figure out what the integral of px is. Okay, and then slap an e under it. That becomes the mu of x. Then step 3, we integrate mu x qx, okay, and then add a constant to it. Don't forget the constant. It's extremely important because the constant is going to be divided by mu of x, which will constitute a big part of the answer. So in other words, the constant isn't just some constant anymore. The constant matters greatly. So each problem, we just go through those steps and out pops our answer. Now, first problem, 225, we have some specific thing here, right? So we follow the rules. First, we rearrange the formula into y prime plus py and qy. Step 2, we calculate what is the integral of p of x, which happens to be some kind of a natural log, which helps because we have to slap the e on it. Here's step 3. We slap on the e on it. It becomes x to the power minus 3. Now, the absolute value, I found that you can more or less ignore it. Just keep an eye on it, see if it does anything weird. But generally speaking, we sort of ignore the absolute value and just keep going. And then I think I made a mistake in here. Okay, so everything fell apart. And put a wrong sign or something, or well, whatever. So we continue to follow the rules. Okay, we're going to integrate this thing, which this happened to be easy to integrate the mu of x q of x down here, and then follow the recipe, and then we come up with the right answer. Here's the answer. As you can see, the answer has c of x right in there. That is, the constant now matters greatly because it's not just the constant. The constant is multiplied by c cubed. So that's the end of problem 225. Next, problem 231, the same thing. We follow the rules. Okay, first we rewrite the formula into y prime plus p of y equals the p of x y equal to q of x. Then we integrate the q of p of x, which in this case happened to be a quick little integral. Then we slap an e under it, and that becomes the mu of x. Then we integrate mu of x q of x, which in this case also happened to be a fairly easy and quick integral. And then finally, we write down what y is. Y is 1 over mu of x times the integral plus c. Don't forget the c. And if we get everything right, then the answer comes out. As you can see, this problem is again arranged such that things are not too difficult. I mean, that doesn't look too creepy. And so everything comes out nicely. Things can look bad very, very fast, as you can imagine, because we have to integrate something and slap that integral inside another integral and integrate again. So yeah, things can look bad really, really fast. But for this section, when we are starting out, this is the introduction of the first order linear equations, linear differential equations. So we're keeping the homework easy, okay, so that we don't get bogged down by details of integration or worse, algebra. You have a mountain of algebra and you get lost in it. That is not really necessary. Right now, we are just going to focus on how to use that one formula we learned about using the mu of x as an assistant, so to speak, in helping us reach the answer. So next, let's look at problem 233, where you have a similar equation that is luckily quite straightforward. We have we have a linear equation which we will rewrite in the linear form, where it becomes y prime plus pxy equal to qx. And then first we integrate px, which in this case happened to be an easy one. It equals the natural log of something. And the minus 2 becomes the power on top of x plus 2. That's the rule of the natural log. And then mu of x then equals to that, which then, because you slap an e under it, right, under the natural log to get rid of it, and then with next thing we do, we have to integrate mu of x and q of x, which luckily comes out looking okay. We didn't get stuck in the mountain of integration. So then if you keep all the negative signs properly, then you have the answer plus c, and the c is again very important, because then we have to divide mu of x to create y. Okay, once you've done the division, which in this case becomes multiplication, because x plus 2 is originally negative power, so it becomes positive power in division, and then you come up with the right answer. Yeah, and this is the same as the answer in the back, so I'm not going to simplify it anymore. That's good enough for anybody, right? And so that's that. Next, let's look at problem 241, where we have still the same kind of deal. Okay, now we have the problem here, y prime plus y equal to x, I guess. Is that our original problem? Doesn't matter. The point is, the only difference is we have an initial condition here. Y, when x is 0, y is 3, but that can be easily arranged. We'll use that condition to calculate the constant c. So following the rules, first we integrate p of x, which is just x, which means mu of x is e to the power x. So then when we integrate mu x q of x, following the rules, that is equal to x e to the power x. Now that you can solve by the integration by parts with the Liat rule, L-I-A-T-E. However, I just pulled out rule 42 on page 700, the integration formula, and then wrote that answer down right away. Now with that, we have y, then plug in the 1 over mu of x equal to that stuff, and that came out with some kind of an answer. And then we plug in x equal to 0, y equal to 3 to calculate what c is, and c turns out to be 4, and that's the right answer. So that's pretty smooth. Again, these are very easy problems, just so that we can practice the formula of the two-step integration to solve the answer. Next, to problem 249, that's quite a bit harder. But the reason it's harder is not because the problem itself is harder, it's just the integration might get harder. And that's the only hard part about doing this, is are you going to be able to get the integration to come out? As we can imagine, integration gets tough really fast. So anyway, let's look at the problem 249. There's a square root in it, which is really not a good sign, right? Things might get the integration might get very, very difficult. But we're going to try it anyway, so we'll apply the same rules, okay, whether it's hard or not hard. And we'll apply the same rules. First, we rewrite it in the standard formula, where it is y prime plus px equal to qx, fine. And then we integrate px, that went over pretty good. That's not a big problem. Then mu of x equal to that thing, which is okay. And then mu of x q of x equal to that. And how do you integrate that? Well, the way I did it is I just pull the indefinite integrator out. I mean the indefinite integral calculator out, and plug it in and I'll pop this answer. Okay, I tried to do it myself earlier and didn't get very far. It was turning into a giant headache. So I just used the calculator, which gave me that thing. And that's just that part. That's only the mu x qx, okay? Then for y, you have to do the division, okay? Divide the mu right out of there. If you divide the mu out, then you get this thing, and you plug in y of 0 equal to 1, and that does give you the right answer. And as long as there's no mistake. See, I scratched something out because I made a mistake in there. In something is 2 or 1. I think I copied it down wrong from the calculator itself. There's this number is 1, and somehow I wrote down 2, so I couldn't get the answer quite right. But once I realized where my mistake was, then everything came out okay. So that marks the end of this section and this chapter. And so next we will do chapter whatever the next chapter is, we're gonna do it. All right.